del ISOC. Van a ser en inglés porque él es esloveno. Y le damos las gracias por haber venido aquí a hacernos estas dos charlas, a hablar sobre RIPE-690 y manners. Thank you, Jan, for coming here to the ESNOG-21.
Thank you. Hello, everybody. My name is Žorž. I'm coming from Slovenia. I work for Internet Society. And yeah, we had quite a long discussion with Joao and Jordi. Which presentation should I present today? Should it be Net64 check or should it be RIPE-690? Because apparently you have already heard lots of this stuff. But yeah, it was said that we should probably do it again. So you will hear also from me what we did with Jordi. Okay. So who here in this room is implementing IPv6? Excellent. Are you operators or operators? All right. So you have probably come to a question. What is the size of the prefix delegation that we should give to our users? And how we should delegate it, statically or dynamically? Did you come to this question? I'm seeing nods. Yeah, well, if you didn't come to this question yet, you will. Quite soon. All right, so does this work? Yes. Excellent. All right. Because I will present about the document here, there will be walls of text. I know the modern presentations are not with walls of texts. It should be just pictures without anything else, apparently. But bear with me. I apologize in advance for any inconvenience. It's a lot of text because you can't present the document with just pictures, right? Okay, what is this document all about? This document discusses the main issues related to the operational practices of the assignment to the end users in IPv6. And I will tell you a story later, but it came out that if you make a wrong choice when you're designing your IPv6 network to your users and also for your core network, you will sooner or later have negative implications and troubles, and you will have to go back to the drawing board and redo it again. There is always a temptation to take an easier and quicker way of implementing IPv6, but usually it doesn't pay off. The easier and quicker way usually comes from understanding of IPv4. So you are very good in IPv4 because you're operators. I spent 20 years in operational. I spent 20 years as running, designing, building parts of the networks. And I know how it's tempting to take it in easier way and just implement it and forget about it. In this case, it's not something like this. Why we started these documents? I work for ISOC, for Internet Society. I travel around the planet a lot. Last year, I spent over 300 hours in the air between takeoff and landing. I went to South America, I went to Africa, I went to Asia, I went all over Europe, and I usually speak to operators around the world. And when I hear, when we discuss DNSSEC or IPv6, when I start hearing always the same question, and when I start seeing the pattern in what people is asking, then I go like, okay, this seems to be a new IPv6 issue. In the past, I started with a very great group of people similar to this, the RIPE-554 that you maybe know. That's IPv6 requirements for ICT equipment that is today translated into 17 languages around the world. Previous one to this was IPv6 troubleshooting for residential gateways. So if you're an operator, if you have help desk, I heard from many people around the world saying, yeah, we deployed IPv6, but now we are not putting it to our end customers because our help desk will just burn down in flames. So we said, okay, let's tackle this problem. And we put together a good group of people, and we have RIPE-691 with an online tool where you can troubleshoot your users' IPv6 connectivity. And then the next generic pattern that I heard from people around the world was, what is the size of prefix delegation and how do we assign it? So we put together, as you can see here, quite a good group of people. We have Jordi here. He did a lot of work in this document. Thank you, Jordi, for all the work and time. And we have, for example, Primož from Slovenian Telecom, Mark Townsley from Cisco, you probably know him. He's one of the Cisco fellows. Andrew Alston from Liquid Telecom. I will tell you a story from Andrew later. Gerd Doering, Jordi, Jan Linkova from Google, Luis Balbinot, he's from Brazil, Kevin Maynell and Lee Howard from, he was the IPv6 guy in Time Warner Cable. So we have lots of experience built in this thing. Why is this thing acting funny?
It's okay, don't worry.
Okay. All right. Let's go straight into it. That's a table of contents. We have executive summary. This was put in as a latest addition, as the last thing that we put in, because people said the management level of people will just go and read the executive summary. I wanted to call it conclusions and put it at the beginning as number 1, conclusions. But then people said that this wouldn't be the wisest idea of them all. So we said executive summary. Then we have, actually, it starts with number 4. Here we discuss the site of end user prefix assignments. Do we go /48, /56, or something else? And then we split into numbering the 1 link, that's between the CPE and the core network. And then we discuss should we go /64 prefix from a dedicated pool of IPv6 addresses, or we go unnumbered, or we go ULA, or we go /64 prefix out of the IPv6 prefix assigned to the end user. So if you give the user /48, should you take the first /64 out of the prefix delegation and the summary? Then we have prefix assignment option. Should we go /48 for everybody? Should we go /48 for business customers and 56 for residential customers? Or should we go with prefixes longer than /56? Or what should we do? It's quite a nice read, actually. After this, number 5 is the end user IPv6 prefix assignments, persistent versus non-persistent. If you think that this one was hard, you're wrong. This one was really hard. Because you need to understand that this document, when you saw the group of people that are there as co-authors, basically the whole document went through a RIPE IPv6 working group and RIPE Best Current Operational Practices Task Force. So we kept sending back the draft. We kept sending it back, and there were comments. So this document is actually widely agreed by the RIPE community. It's not just that 10 or 12 people that you saw there, but there was lots of comments coming back from the community, and this means that actually it was quite a big fight. Even 2 years, yeah. So the whole community was all of a sudden, I need to go here because there is a draft straight into me. I'll be there tomorrow. All right. So yeah, it was a big fight, even among the authors. For example, Gerd Doering was sort of like, why would you go static? Why don't you do dynamic? In IETF, we have these protocols that will, and we went like, Gerd, we're talking about today. This is best current operational practice, not what's the dreams for the future from the IETF. IETF is nice, IETF is fine, and it is deciding protocols and designing protocols that will come into the real life in 5 years. But until then, we need to find the lowest common denominator that an operator deploys IPv6 and it will just work, right? Okay, so let's see, what is a generic set of recommendations? And operators, please, that are deploying IPv6, if you disagree, just put up your hand and then explain why you disagree, all right? You have a deal? Okay. Right. IPv6 is not the same as IPv4. I hope we agree on that. All right? Okay. In IPv6, you assign a number of /64 prefixes to each site. So they can have as many subnets as they wish. Now, don't bring your IPv4 thinking into IPv6 thinking. In IPv6, we don't count addresses. In IPv6, we have a subnet that has a meaning, that has a ways of using it. /64 is for one layer 3 segment, right? That's for one layer 3 segment. Does anyone know how many hosts we can put in one /64? Come on. How many hosts we can put in one /64? It's actually very simple, all of them. Because the MAC address is 48-bit, right? We don't have enough hosts in the world that we can put in one layer 3 segment. If you run out of space when you deploy it, go back to RIPE-NCC and he will tell you. And he will tell you, yeah, we will gladly give you more IPv6 if you need it. So don't bring bad practices from IPv4 into IPv6. Start clean, start fresh. Okay. If you want a simple addressing plan, then you should consider these 3 options. One, /48 for each customer. This is the easiest one. RIPE-NCC, if you say, I have a customer, you can assign /48, and they will gladly say, no problem whatsoever. You don't even have to explain it. It's /48 per site, not a problem whatsoever. If you put /48 for everybody, then you also have quite simple routing tables. Everybody is the same. Every route is the same. Every routing slot is the same. So, we are all equal, but some people is more equal than other. And this happens if you go to, if you try to differentiate amongst the types of customers. I heard lots of people saying, but our marketing and sales guys, they want to differentiate between a business customer and a residential customer. Okay, then give the business customer /48 and give the residential customer /56. And that's the Solomon's solution. There is technically no reason why you should go 48-56 because you have then different prefixes. But it's nothing wrong with that. It's just everybody is equal, but some is more equal than other in this case. You can go, it works fine. Just do it.
HomeNet in the future.
HomeNet, yeah, well, HomeNet in the future will cause you some gray hair, but let's see if HomeNet gets deployed anyway. So if I would deploy it, if I would be a consultant for ISP to deploy IPv6, I would go /48 for everybody. This is future proof. You don't have any problems and so on. Okay. There is a specific case for cellular phones to be assigned /64 per device because PDP v6 by default assigns the whole /64 per device, and this is what it is, and see it's outside of the scope of this document. Don't go with longer prefix than /56. Just simply don't. If you can avoid it, just don't give them less space than 56, because in the future you will have. There will be use cases there will be applications, there will be things that you will need more space. For example, there are discussions and also the prototypes built by Google people and also some other people. And there is, I think it's the internet draft out there that assigns a /64 per host. That means that you can give each daemon on your host its own IPv6 address.
I am presenting it tomorrow.
Exactly. This is so cool because, for example, you can get rid of the layer 4 ports. You don't need ports anymore because your HTTPS daemon is listening on an IP address, and you send packets to the IP address. And then you can do your security based on layer 3, not on layer 4 anymore. Things like this. This is the future. These are cool things in the future. Think about this. Sorry?
No.
Yeah, okay. These are cool things in the future. All right, I think I need to go a little faster. I could talk about these things for hours. Okay. In order to facilitate troubleshooting and have a future-proof network, consider numbering the one link using the global unicast addresses, using a /64 prefix out of a dedicated pool of IPv6 addresses. That's quite simple. You put there a big pool of addresses. When the CPE connects, it gets the /64 out of a pool, and it connects. It can be static, it can be dynamic. Basically, it doesn't really matter. You could decide to use /127 for point-to-point links, but please, we have seen failures if the /127s were allocated out of one /64 and one after another. This is not a good idea. Allocate a /64 for each link, and then for the next link, you allocate next /64, and just use /127 out of the /64. I know it sounds wasteful, but it's not. We have enough of these addresses, more than enough. Okay. Non-persistent prefixes are considered harmful in IPv6. What are non-persistent prefixes? For example, Germany people decided to change the prefix every 24 hours. And all of a sudden, in the middle of the night or middle of the day, your prefix just changes. And in IPv4, when you had one IPv4 address and then NAT, and then the private address is behind the CPE, that was fine because you couldn't care less. The IP address changed, your network stayed the same. In IPv6, there is no NAT. Okay, there is NAT, but don't use it. It's worthless. So you have public IPv6 addresses on your network. Maybe you have multiple subnets behind. And now all of a sudden, your ISP changes the prefix. So you have to renumber the whole network behind the CPE. And that's not seamless. There are lots of failures. I can tell you the story from Africa. Liquid Telecom, our friend Andrew Alston. He implemented IPv6 in Kenya. And after some time, he comes over Facebook chats and says, Jan, hey, help, Google stopped serving quad A's to me. Okay, why? What happened? And then he started explaining me, and then I go, okay, stop. How did you implement the prefix delegation? Did you implement it statically or dynamically? And he said, oh no, I just put a big pool on the BNG, and then whoever connects gets the next one /48, and you know. And I said, okay, I have been to Kenya. Sometimes it's 30 hours without electricity. There is no day that passes by without the electricity outage. So every time the CPE power booted, it got different prefix delegation. So what happened was, when a user was sitting at home on the couch with the laptop connected to whatever network he has at home, he had the IPv6 address from the prefix delegation that he got before the power outage, right? Because the laptop doesn't reboot because of power outage. Power came back, CPE booted, got a different prefix, but then the CPE didn't remember what was the previous prefix delegation. Okay, Germans fixed this part because Fritzbox remembers over power cycles what was the previous prefix delegation. And just got the new prefix delegation and started announcing the new addresses without sending array packets with lifetime 0 to remove the prefix from the network and renumber the whole network. So all of a sudden, this guy was sitting with the laptop with all IPv6 address, old one and the new one. And by Murphy's law, the machine decided to still send out packets with the source address of the old prefix. So what happened was, because it didn't implement the anti-spoofing properly, the packets via default routes made it out and made it to Google, right? If you typed in google.com. But then when packet came back, it couldn't find the way back because there was no route pointing back to the CPE. So he sent a SYN. Google sent back a SYN ACK that never made it. But Google is measuring. If we send a SYN ACK, we are expecting ACK. If we don't get ACK back from this IPv6 address, we mark the whole ISP as broken IPv6 and stop serving Quad A, stop serving IPv6 traffic, stop serving everything. Put him on a blacklist, off you go. Of course. I explained this to Andrew. It was sort of like, and he said, Jan, I spent 3 days troubleshooting this stuff, and you managed to troubleshoot it in 5 minutes over Facebook chat. What the hell? I said, don't worry. Just go, deploy it statically. After 3 days, he comes back and says, I deployed it statically. I had to redo everything. I had to redo the addressing plan, and now it works. I phoned Google, they put me off the blacklist, they confirmed that the whole thing is working. Now we put it in statically and I'm off. And now I never heard since from him on this topic that things would not work. So dynamically changing the prefix, if you want to have troubles in your help desk, go and do it. Okay. This was the picture from a RIPE meeting in, was that Budapest? Here are the authors. This is Lee. This is Andrew Alston from Africa. This is the guy who broke the IPv6. He's a great guy. This is Jordi. Probably you have seen him before. This is Sander, and I have no idea who this guy is. Okay. All right, acknowledgements. You can see in the document there were many people commenting and sending back the ideas, corrections, feedback. So this is actually a document that nobody can tell you that it is vendor not neutral or things like this. It is completely a community document and at the end, basically Jordi and I became just a humble editors. At the beginning, we had the ideas and put in the ideas, but at the end, we just became humble editors on what came back from the community and tried to keep up with the document and all the stream that came in. Where to find the doc? Yeah, we got a consensus, and it's RIPE-690. It's there, it's yours, it's free when you need it. And I've seen, I got many. Lots of feedback from all around the world when people is telling me, Jan, this is gold. We just printed it out and just took it to our manager and said, I decided we go /48 for everybody, and here is a document that is supporting it. This is the best current operational practice agreed by the community. Now, bugger off. Okay, fine. We have some future works and ideas. Now it's a little bit stalled, but the next question that I hear on IPv6 from operators around the world is how the hell to run the mail server on IPv6 and survive all the spam. Not the sending email server, but the receiving email server. So you have anti-spam mechanisms, IP reputation mechanisms. IP reputation we don't, because in IPv6 it's different and much more complicated. So we will probably restart the work. We have a good team now. If there is anyone here that is running mail server, the receiving mail server on IPv6 and have experience what to write in the best kind of operational practice, how to do it, we are more than happy to hear about it. Jordi is again part of the team. So talk to me or to Jordi, and we can make it work somehow. How much too long was I?
No, it's fine. It's perfect.
It's fine. It's perfect. Okay. Are there any questions other than Jordi? No? Okay, Jordi.
I just want to comment something. I think you didn't mention it. Just 1 year ago, I did the same presentation. Basically, at that time, the document still didn't have the right number, but the content is the same. We just got the right number after my presentation. So if you want to have a presentation in Spanish, I think we have the videos for that in ESNOG, right? So you can have the video, and it was a presentation with all the details. Okay, that's one question. The other point is, I think you didn't mention why we decided to go to persistent versus non-persistent. You didn't explain that.
I explained the whole story. Yeah, but go ahead, tell me.
The point is, when we say static versus dynamic, many people get confused. So that was what we decided to use a different terminology. So you can use persistent, but not necessarily use a dynamic mechanism like DHCP-V6. So it's a different thing. It's just to avoid the people to get confused. And the last thing I have is, I talked with a lot of people from Germany, and I got also the same idea that Jan explained, that the regulation forces them to have dynamic prefixes, but it's not the case. What the regulations say is you need to provide a way to the user decide if they want to have a static or dynamic. Better said, persistent or non-persistent, to avoid the confusion. So I think that's very important, because many people get confused with this type of OAX, and it's not a real regulation problem. And in Spain, in fact, we don't have that problem as well. So we can go that way. And I also asked Juanpe to put in the screen, because I started 1 year ago, more or less at the same time as this document. I started to write a document on ITF that is in part touching this. This document I started already in 2006, but at that time the community didn't agree, so I restarted the work now. So we will have in the screen the URL for that document in case you want to read that. It's somehow complementary to this work as well. Thank you.
Mm-hmm. Yeah, so thank you, Jordi. You can, wow, I have a display. You can still use DHCP-V6 for prefix delegations easily. Just set up the lifetime of infinity, or at least for the time of the contract of the person with you, or set it to infinity or something, or 100 years, something like this, and make sure that people get the same prefix back every time. Okay, if they move houses and they connect to different BNG, then this should not be a problem, because they need to disconnect everything, go there, connect, and they will get new addresses if you want to connect them to new BNG. But don't do it on a live cycle. And for the end, can you read this? A home without IPv6 is just a house. Thank you. Questions? Come on, don't be shy. I still have 15 minutes. It says. Huh? Okay.
When do you foresee full adoption of IPv6?
Where do you see the full adoption?
In Europe, at least.
In Europe. Well,
which country?
Currently, generically, Google measurements, they measure for all their services, YouTube, search engine, ads, whatever they have. They measure, they log the traffic that is coming from the whole world to their services. And currently they see 25% of traffic is IPv6 already. So it's not a joke anymore. It's not sort of like 0.5% or 1%. It is 25%. It's 1/4. That means that there are many eyeballs that are sending packets over IPv6 to Google. That is these days probably the biggest service. And Facebook sees similar thing. Mobile networks are a little bit ahead of the game because on mobile networks it's quite easy to implement IPv6, and basically they go IPv6 only with Net64 or 464 XLAT mechanism. So now we have, I don't know, T-Mobile USA probably these days has
89% total in US.
Yeah, but they have sort of like 80 or 90 million mobile phones on IPv6 only. And then you have Verizon, Wireless, and you have other operators that have millions and tens of millions mobile phones on, and they see no problems. I asked one of these guys, what happened when you enabled IPv6 only for the whole sort of like 50 million users? And he said, well, nothing really happened. I said, did many people call back to your help desk? And he said, no, actually on that day, more people called the help desk and ordered pizza, a wrong number, than had IPv6 issues. So it's sort of like it's quite easy. For mobile operators, it's quite easy. Classic ISPs for the landlines, fiber, copper, they tend to get more confused, but that's why we are writing these documents to unconfuse the whole thing and set things straight. But there is a lot going on. When I'm talking with these people, there's a lot going on behind the curtains. A lot of testing, lots of labs. They're doing the tests with the friendly customers. So you can see here and there a big pop, a big spike in some countries, and I have a feeling that we will see more and more of these spikes when a huge ISP just decides, okay, we are ready, we have everything in place, and just enable it for everybody. So it's progressing quite nicely, basically.
Thank you. Now one question. I haven't read the document. I don't know if there are or there will be use cases, because I think you gave a very nice example with this Kenya issue, and it's a typical example of something that is a solution in such of a problem, which is something that happens a lot when you are deploying something. You have 5 questions to answer, 5 decisions to take, and nobody knows the answer. For example, how many addresses do we believe our customer will have? We don't know. So 20 million, why not? I remember, when IPv4 began to get exhausted. Never thought before. Everybody was happy in heaven, and then everybody was doing a very bad use. They were greedy, not using them. Now this solution, it was sold. Can remember this guy 18 years ago? In Madrid, giving away T-shirts. You have mine. We were younger, we were thinner. Yeah. It was great. IPs for everybody. Then why worry? We can give millions to every household, even the light bulbs. But you know what? When you go out of the lab, you go to the meeting room, you have to give exact answers. Persistent or non-persistent, why?
It's
how?
It's written in the document.
And someone is going to tell us, use case, give me a medium household, give me a small, give me a very sophisticated customer.
Go with persistent and go with /48. Does that answer your question?
And see what happens. Yes, definitely. I will make a tattoo out of that.
Exactly. Yeah, it's that's actually why we wrote this document, because everybody was asking the same questions. And to your point of exhaustion of IPv6, I made a quick calculation probably 10 or 15 years ago. So currently we have 5 RIRs around the world, right? Each continent, each own one. If we would have 1 million RIRs that would be distributing IPv6 space, and if we
in the proper manner.
In a proper manner. And if each of these RIRs, not 5, 1 million, it will never happen. We will never have more than 5. If they would just put in the database, sort of like name, surname, company, and your prefix allegation, and let's say we need 30 seconds for each /32 or /29, we would need 500,000 years just to distribute the space to operators, just to distribute, not to deploy and start using it. 500,000 years, 500,000 years, just to distribute it. So I think we are in a pretty good spot here. Yeah.
I have done the maths. If we assume that we have 25 billion humans and assign each of them 4/48s, which have only 50% routing efficiency, we can repeat that 2 at the power of 10 times, and assuming that every human lives for 100 years, and we don't recover back the /48s, we will be able to do that for over 100,000 years. That's maths.
We'll cover that.
And then we can recover those that are already dead.
All right.
So
that's a new ITF document that I am writing.
yeah.
All right.
So the
I mean,
don't go crazy with IPv6 addresses, but you can use it generously. Does RIPE-NCC has anything to say about this?
Approve.
Approve. All right. If there are there any other questions?
Yeah, one very fast.
Okay.
Do you know that a lot of people is very concerned with SEO, search engine optimization, and there are several factors which Google will account for to give you the rank like HTTPS, HTTP2, and many other things. The question is, if you're serving the traffic with IPv6, you will get a better ranking from Google or not?
Now you are rubbing me the right way. I will show you the document that I put on go6.si in 2010. And it's a suggestion to search engines. Is that it connects from here to my to Go6 lab. It's extremely slow. Let me see if this will work. Okay. You see? 23rd of August 2010. And here is the abstract. Deployment and adoption of IPv6 is slow at this point in time. This can be a risk of future growth of the internet. One of the observed obstacles is that content providers are waiting for IPv6 viewers, and viewers are waiting for IPv6 content. This was 8 years ago. We propose a slight change in the search engine scoring algorithms to stimulate content providers to make their content accessible over IPv6. Was this a question?
That was a question.
Yes, and I went back to Vint, to many other people every year, basically, and they still are responding, we are not ready yet. We have your proposal in mind. I know it's 8 years, but we are still not checking all the parameters over IPv6 fully. We are testing it on a 20% of the cases. We don't have guts yet to turn the knob to 100%, so we would test all when we release the spider to go around, to test the IPv6 for 100% yet, but when we decide to test for IPv6 100% of the sites, then we will turn on the and manipulate the search engine algorithm. And I said, dear Google people, when you do that, please send me an email. I will personally make a presentation and go around the world and go to these SEO search engine specialists, marketing people, and tell them, look, if you deploy IPv6, your ranking will be, your score will be higher, and then you will see a massive stream of people going to IPv6.
Yeah. All ISPs.
Yep.
And all, yeah, of course.
So, yeah, this is basically set in motion for 8 years already.
All right.
Yeah.
I have the same question for the previous presenter on DNS, but we didn't have time for that.
On DNS?
Yeah.
What is the previous presenter?
Code
999.
Yeah.
Oh, code 9999. Yeah, it's
a speed factor. It's a security factor.
Is the same question.
Yeah.
Let me see. I have a panel here. 5 minutes. All right. We have 5 minutes more. Thank you. This is quite nice, actually. No more questions? Okay.
I have a question. Do you have a lot of tools to sell us or to sell to the ISPs to use IPv6? How we can sell to our customers to sell IPv6? Because I can give a customer, okay, imagine a big customer with 1,000 PCs or whatever, and I say, okay, I will give you a /48/56, and then you can use IPv6. And they say, why?
Okay.
Why I need to use IPv6 if I use IPv4 with an IP address or even with a little subnet? The problem is to sell IPv6 to the final customer.
You shouldn't. You actually shouldn't. IPv6 is not
No, because they use his own subnet in his network, in their own networks.
So for ISP, IPv6 is not a business upgrade. It's a technology upgrade.
Yeah,
It's
I know.
sort of like, if you would still be running the network on Banyan Vines or IPX or DECnet, you would be rather old, right? So, this is a technology upgrade. How you persuade your business customers to use IPv6?
Okay, now it's working. Why I should change?
Because
it's difficult to sell.
You know why?
To
You know why? Because internet is growing exponentially, and now we see customers that are on IPv6 only, and that's why we next time or maybe tomorrow, if we have time, I have a presentation on Net64 chat tool that we built with Sander Stefan together. That is actually directed at those people who are left on IPv4 only. Because if you are serving your content on IPv4 only, and you have IPv6 only users and mobile phones that needs to access your content through Net64 translation engine, the user experience is much worse than you can imagine. If you would put your content also on IPv6, the thing would go straight directly end to end. There would be no translation in between. And there are many customers showing up, millions and millions and millions of it, that have just IPv6 on their device. So if you as a business customer that is offering content on the internet, if you don't have IPv6, then these people will have much worse user experience at the end.
I had no customer who asked me for IPv6.
You should tell them to use it.
And I tell them, and say,
So,
why I need it.
what usually operators do?
For us, is the main problem to sell IPv6. I
shouldn't.
can give IPv6, but they
So
I don't want that.
what usually people do is they provision it for the residential customers because the CPE.
We don't work for residential customers. We just work for.
No. I'm telling you what's the usual stuff. Usually, they provision it for the residential CPEs that gets the IPv6 address on the LAN side, and everything just works. End user even don't know it. So if people don't even notice that they got IPv6 and IPv4 all of a sudden, then you did your job right. That's the thing. If people even don't notice, then don't even tell them they have IPv6, because then they will call a help desk and go like, oh, something is wrong with this new IPv6. Don't even tell them. Just enable it and leave it be. People will start using it. But for business customers, usually what people do is they just provision it. They put in the documents, this is your IPv4 subnet, this is your IPv6 subnet, this is IPv4 point-to-point link, this is IPv6 point-to-point link. Here you have it. And then you go like, we encourage you to use it and configure it. And then people will start using it at some point in time. You just enable it and then...
You know Spain. You
Okay,
don't know
well,
Spain.
we don't know.
Well,
You don't know Spain.
I think we are on the same...
It's the same. It's the same in every country.
it's the same in
Not
every
just Spain.
country.
Yeah.
Okay, yeah?
I would say that if all the end customers already have IPv6, then enterprises will have to go.
Exactly.
Exactly. Because when you have users that, currently as said, there is 25% of traffic coming to Google on IPv6. So those people who live on IPv4 only will have to start thinking sooner or later.
Yeah, but they don't have any rush.
Well, give them time, Jordi.
Answering the question in short, for residential customers, there is already a problem with the carrier rate maps. I know it's for residential customers. For example, Sony PlayStation is blocking the IP ranges. Maybe in a corporate customer you don't have such kind of problem, but you will find sooner or later other problems. For example, your corporate customer need more IPv4 addresses, and maybe you cannot provide that.
We don't
Maybe.
provide subnets to our customers.
But maybe you, but not everybody is able to keep providing IPv4 addresses.
They have their own private IP address behind that, and that's working for them, and they don't think to change. They don't,
Sooner or later they will feel the pressure.
probably
Yes.
sooner or later, but
I mean,
for the
probably
moment, seems that will be later.
the residential market will push them as already has been told, but I really think it's going to happen. It's happening.
All right. Okay, we have been told to stop. Time out.
Politely.
Politely. Thank you very much.